Hello?
Yeah, afternoon.
Oh.
Hello.
Oh, okay. Wait. Okay, so today we will continue our assembly language. So we will learn. We will continue the last week punya lecture. So today we will learn about some few concepts and the syntax and then the instructions, syntax lah, on how to do things in assembly language. Okay, wait, I share my screen first. Tomorrow, hopefully, we can start doing our first program in assembly language lah. Okay.
I missed the got water sound.
Pardon?
Got water sound.
Got water sound? Right now. Now, still got water sound?
I don't know what sound is that. Oh, it's gone. I think.
Oh, wait now. Now, okay. Hello?
Still got. Never mind.
Cannot, my voice is not clear.
The voice clear. It's just the background sounds very.
Previously, you didn't hear the sound lah, only today lah.
Yeah, I think. Never mind. Still can hear. Still can listen.
Oh, okay. Okay, so wait, I record our meeting first. You guys can see my screen?
Yeah.
Okay. Okay. So last time, if I'm not mistaken, we stopped at in this part. Am I right?
I think so.
Okay. So also we start on this topic lah. Okay, so we learn on how in this topic we learn how to define the word and S word. Okay, so there's a difference between this nih. Okay, so if you remember, I think, yes. Okay, we have covered this data definition. Okay, I think this one also yes. This one also yes. Ya, memang the word and this word lah. Okay, so defining word and S word data. Okay, so when we want to define or declare a variable in type or in size of word and S word. Okay, so there's a difference between word and S word. Okay, so for the 16-bit integer, meaning if your data that you want to declare will occupy 16-bit inside your memory, so you use word and S word. But there are difference between word and S word, which is you use word when you want to declare an unsigned value, but you will use S word if you want to declare uh, integer in type of value. So you know the difference between signed and unsigned, kan? So we
Yeah.
have learned it. We
Positive and
have
negative.
learned it previous. Yes. So unsigned is only containing positive. Sign is containing positive and negative. Okay, so for the word type, bukan type, for the word size of variable, this is the largest value that we can store in type of word, or in size of word, in size, not in type. Usually when we are declaring a variable using the higher level language, we will use, for example, integer, string, kan? It is telling about the type of the data. But in assembly language, we are not using the type of the data, but we will learn later on how we will declare the type of the data. But in assembly language, we define the size of the variable first. Okay, so all of the either word, S word, all of this can, it is telling about the size of the data that we will store in memory. Okay, so for the 16-bit, so we can use word or S word. And then this is the smallest sign value that we can store using, because the memory only can store up until 16-bit integer, kan? So this is the smallest that can be captured by 16-bit integer, and then this is the largest value that can be stored inside 16-bit integer. Okay, so for when you don't know the value of the variable that you want to store, so you can just put this question mark. Okay, so you can use this syntax for uninitialized and then for unsigned, because it is word. And then if you want to initialize something that you don't know, but in type of sign value, so you can use word, word tree, I mean the name of the variable, and then S word, and then questions mark for uninitialized and sign value. Okay, so after that, this is how you declare a word, or sorry, a variable in size of word. In size of word, remember, if it is word or S word, it is 16-bit integer. So if you want to declare it in string or text, so you can put the double quote, or single quote lah, double character. Okay, so if you want to declare an array, but in size of word, so this is how you can declare it. Okay, okay, so this is for when you don't know the value of the array, but you know that you want to store and up until 5. I mean the size of your array is until 5 array. Okay, so for example, this one, 2, 3, 4, 5. Okay, so this is 5, but this declaration is when you don't know what is the value the uh, of the array lah. Okay, so this is how we declare an initialized array. So after that, we proceed to the D word and S word. So if it is D word, meaning it is double word. Double word meaning 32-bit integer, because a word size meaning 16-bit, kan? Okay, so for the double word, it means that it containing 32 bits integer, meaning we need to allocate 32-bit space in memory in one segment of memory. Okay, so the same with the previous when it is s, when there's a set s in the size type, okay, in the size type of the data, so it means it is for sign integer or sign value. Okay, so it is the same with the previous, meaning this variable you want to it has this value, and then you will allocate 32 bits integer in memory. And then this also, for this one, this means that this variable will occupy 32 bits space in the memory, but it also can store a value in type of sign. Okay, so this is how we will declare for unsigned array and unsigned and uninitialized, meaning we don't know the value yet. And then this is how we declare an array that we already know the value. Okay, so after that we proceed to the keyword. Keyword meaning um, double the 32 bits, double the D word. Okay, so meaning 32 multiply 32 meaning 64 bits. Okay, so whenever we what we declare a variable in type of this, meaning it will allocate 64 bits inside your memory for that variable. Okay, so this is how we will declare it. For this terabyte ini, I don't know how many the words or how many byte here, but it is a lot lah, a lot of word. Okay, so terabyte. Okay, so after that, this is how we will declare the real number. So I think we haven't touched about the real kan. We only until the exponent too. So later we will get back to that. Okay, so this is how we will declare a short array in type. Sorry, in yeah, in type of real, in type of this real number also, but it can hold the real number, but um, in real four lah. Okay, so this is how we will. For this one, it is an array. We know the size of the array, which is 20, but we don't know the value, but we know that it is in format of this. Okay, so it has, for this format, it can tell that the value inside this array should has one decimal places. Okay, so after that we proceed to the symbolic constant. This symbolic constants kan, it is actually an associate and identifier for a symbol with an integer expression or some text. Okay, so we didn't use this alone because we will when we want to use symbolic constant, we need to use it with equal sign. Okay, so but before that, we need to learn about the symbolic constant first lah. Okay, so the symbolic, doesn't reserve any storage. So when you declare a symbolic constant, you didn't allocate any space in the memory because it will hold. It can be, I mean, this constant will only be used by the assembly when scanning a program, meaning the value of the symbolic constant only hold in the RAM, in our RAM, but it is, it is only it is only have the value when you run the program, but after that, after you stop compiling, the value will lost lah. So you cannot change it during the runtime because it is predefined. Okay, so it is the symbolic constant is used with equal signs directive. Okay, so how it is used is by this syntax. First, we will put the symbolic constant in the name part here. After that, we use the equal and then the expression. Okay, so the expressions here must be in 32-bit integer. So you can put either expression here, for example, for the real number just now 0.0, meaning it is telling, the expression is telling that the the constant having the, it should have format one decimal places, or you can directly put the value of the constant here. Okay, so for example, this one lah. For example, you set count equal to 500. Okay, so this is a constant. Okay, so you can also put expression here. For example, you can say that variable 1, it is equal 0.0. Okay, so it may be redefined, meaning you can redefine it. Maybe if previous, in the previous at the first row, you define it like this. After that, at the second row, you can redefine what is count again. Okay, so it is a good programming style when we use the this symbol lah. So this is actually like static or public variable if if in our higher level programming language lah. So after that, we learn how to calculate the size of array and the size of string. Okay, so to calculate the size of an array, so we use this symbol. Okay, so this symbol is very powerful because it is actually um, telling the current location counter, meaning it is telling the current process when where it is um, where is the current process or current value punya location inside the memory. Okay, so how we can get the size by using this current location counter is by we we subtract the current location counter with the size of the array so that we can get its size. Okay, so the size of the array we can get by getting the difference of the current location counter with the size of sorry, not with the size of the array lah. Okay, so if we want to get this is the syntax, we just need to follow this syntax if we want to get the size of this array. But when you get uh, that result, or when you get this list size, it will be in byte, meaning when it says that the size of this is one, maybe the for example the list size here it is 4, meaning to say that it is 4 bytes, meaning there are 4 multiply with 8, because 1 byte equal to 8 bits kan. So if you want to get it bits, its number, I mean in its size in bits, you need to multiply with 8. Okay, so let's say you get the size or list size of this is 4. So it means that it is 4 bytes. But if you want to get the size in bits, meaning you need to multiply the 4 with 8, because 1 byte equal to 8 bits. Okay, so, but there are a rule for using this symbol, because you need to write it immediately after the list. Meaning, if you want to know the size of this, you need to immediately letak the what this declaration under this list. If you have another array, for example, list 2 byte, and then you want to get dia punya value kan. Okay, wait, I want to here. Okay, if you guys can see. Okay, so let's say you have another list or another array. Let's say we name it as list 2. You cannot make it like this. Equal to size 2 or ini. You cannot do it like this. Because dia punya rule is you need to put this you need to put it like this. Okay? Can understand ka? The rule of this when you want to use this value or this symbol. Okay, kayang this one. Which part do you unclear? Hello?
Uh,
Yes.
I think need to digest first.
Oh, okay. So I will repeat. In this topic, we are learning about how to calculate the size of an array and string. Okay, so the first way is by using this symbol. This symbol we called as current location counter. So how to use this symbol to calculate the size of the array is, let's say you have declared an array, and then to get the size of this array, you have and then you want to use this symbol to calculate it, this current location counter. So you need to directly put, I mean, this is the syntax lah, the way how we will calculate this size. Okay, so after that, you need to put it immediately. This one, um, if you want to calculate this size of array, I mean the size of this array, then you need to put it is immediately after you declare this variable. The example I choose here, I mean I show here is, this is correct. This is the right way. The right way of doing it. Okay, so you cannot make it like this. And then usually kan we are in a higher level language, we can just we can just write like this kan, as long as the variable name is not the same. But in this assembly language, if you want to use this, the current location counter, you cannot make it like this. You declare all the variable first, baru you declare the size of that array. Cannot. So if you want to, the correct way of doing it is like this. You need to put the size. If you want to calculate it, you need to put the size exactly after you declare the list. Okay?
So the
Yes?
size must
Pardon?
have the list size.
List size. Oh, okay, salah. Yang ini this one salah.
I mean, it must exist there.
Oh, this one, this list size.
Yeah.
Oh no, this one you can just rename it to anything lah. Maybe you can say that this is apa saja lah variable name. This is not compulsory. The compulsory one is this one.
So if no, this line don't have, cannot function.
Pardon?
This size, if don't have, still can
Yeah.
function.
Cannot. This is the compulsory one.
Okay.
Okay.
Because the most important thing here is this sign, because this sign showing the current location counter. That's why you must put it immediately after the array punya declaration, because it is pointing to the current location counter. If you put it macam previously, then it will have different value already, because it is pointing to the wrong class already. Okay, so that's why you must to put it like this immediately after you declare the array that you want to calculate its size. Okay, so after that we proceed. Okay, so if we want to calculate the size of a word array, a word meaning how many bits? Who remember? Word.
2 kah?
16.
Bits. Noel, yes, ngam. 16 bits. Okay,
Oh,
so
okay.
yeah, if bytes, kalau bytes barulah dia 2, because 1 byte is equal to 8 bits kan. For a word size of array, meaning it has 2 bytes. Okay, so remember a word size when when we mention about word, meaning it is 16 bits or 2 bytes. Okay, so when we want the size in size of word, so you need to divide the size that we get previously, because this is in type of byte kan. Okay, so you need to divide it by 2, because we want to get it in word size. Okay, so after that, if you want the size in double word, meaning 32 bits. 32 bits equal to 4 bytes. So the double word is equal to 4 bytes. That's why you need to divide it by 4 because this list size is in byte. So in bytes lah, in bytes. So if you want to get it in double word array, meaning in 4 bytes, I mean because for a double word, it containing 4 bytes, so you have to divide it by 4. Okay, so after that, we learn about EQ directive. EQ directive, it is actually helping us to declare a variable. Okay, so previously, so we proceed. So this EQ directive, it is helping us to declare our variable. Okay, so EQ directive, it define a symbol as either an integer or text expression. And this is cannot be redefined, meaning it is static. You cannot redefine it in another line. This is static. So the syntax of EQ is you may have the name of your variable. After that, you must have this EQ and then the expression. So the expression here may be the 0.0, as I said previously, or maybe a constant. And then this is also you can make it, or you can use the EQ directive to get the value of another variable, or we can call it as a symbol. So you can make the EQ directive holding another value that is from another variable. Okay, so you can, the symbol is maybe existing symbol name. Maybe you said that this is a variable one. Okay, so in this variable two, you said that EQ variable one. Okay, so you can use this EQ directive to hold another variable value. And then after that, you can also use this EQ directive to hold a constant text. So you can put any text here lah. So how we use this EQ directive is like this. Okay, first we will put this. It is not inside the data punya sector lah, inside our assembly language. So we put it outside the data sector. So we may set that this is the sample of EQ directive that holding the expression. For example, you said that this variable holding a value, or sorry, it should be in this type of data, and then this variable is holding this value pi, kan, pi is pi, so it is a constant. Okay, so you can say that this variable is holding a value of this. So this is, you cannot redefine it because it is like static and public punya variable. So you can use this inside your data. Okay, so because in your data, the way we declare the variable is we put the size of the data. Okay, so for example, we declare the prompt variable in size of byte. and it should containing press key. So this is the press key. Okay, so that's why I said the EQ directive is actually helping us to declare any variable. Okay, so for example here, you are declaring a variable mi, and then it is should be in size of word, and then it should have the expression like this, like the matrix punya expressions. So this is how we declare, or how this is how EQ directive helping in declaring a variable.
Why the
After that, yes,
why the matrix don't have the bracket?
pardon,
The
why the
bracket,
matrix?
because yeah, the
Oh,
more than less than symbol.
oh, you mean all of this having this apa kan?
Yeah. Why?
Only yang di sini this is not kan?
Yeah.
This is like a value, the
Uh,
value. So
okay.
this is the expression. So this is not holding the value. This matrix is holding the expression. Expression. So that is the difference between this and this.
Okay.
Okay. So we proceed to text EQ directive. So we use text EQ directive to define a symbol as either an integer or text expression. So we another name for this text EQ is text macro. Okay, so but the difference between this and the previous directive is this directive can be redefined. Okay, so for example, we have this text EQ directive. So it is previously declared as having this text. Okay, so this is another constant lah, constant. Okay, so after that, um, excuse me. So after that, in the data, we can use the continue message here, meaning we declare this variable in type of byte and it containing this value. After that, so we have another variable which is the name is the count, and then we can also use text EQ in the data punya sector. Okay, so the difference between the EQ and text EQ, for text EQ you can use it inside this sector. So that is its mean by it can be redefined. Compared to the EQ just now, you can only use it before the data punya sector lah. Okay, so for the text EQ, it can be used inside the data punya sector. Okay, so after that, we proceed to the real address mode programming. So the real address mode programming meaning it can generate 16-bit MS-DOS program. So the advantage of the real address mode programming is it can enable the calling of MS-DOS and BIOS function, no memory access restriction. Okay, so but the disadvantage of it is um, we must be aware of both segment and offset because it is only use 16-bit segment in our memory. So, and then we cannot call the Win32 functions. For example, we cannot use any functions from the predetermined library in the Windows. Like I think we have mentioned. I have mentioned about that in our previous lecture. The IRVIN2 itu adalah the library, the external library, but in our Windows itself, it is containing a library. So that library you cannot use in your 16-bit program because that library in type of 32-bit. Okay, so it this this real address mode programming limited to only 604 kilobyte program memory. Your program can only in size of this. It can only use up until 64K kilobyte program in the memory. I mean, yeah, you only can generate or code a program that in type of this. Okay, so we proceed to the data transfer. So we will learn some of the like MOV here, add, subtract. So it means data transfer because when you do that operation, it will move your data from here to there in the registry. Okay, so we first learn about the MOV instruction. So this instructions responsible for to move a data from source to syntax. Sorry, from source to destination. Okay, the syntax is we just put this is the compulsory term move. Okay, and then you can specify the destination and the source. Okay, so this destination and this source is the registry punya place. Okay, the name of the registry. Okay, so the no more than one memory operand permitted, and then we cannot use the registry CS, EIP, and IP in the destination. Okay, so other than this registry can be used as a destination. Okay, so no immediate to segment moves. Okay, after that, this is the example of the move instruction. So for example, we have two variable here, which is we called as count and v and w val. Okay, so we want to move this count inside this registry. Okay, so we want to move this value inside this AX. And then after that, we can also move the value of any registry to the variable. But if you make it like this, you want to AL, AX, EAX. So this code will produce error because AL beta count to EAX, because you know here kan the the count is in type of byte. meaning it only specify 8 bits location, but EAX is actually 32. Dia punya size is 32. If you want to be more clear, is like this. If your program is, we are doing programming in 16 bits, we only can use AX, BX, CX, and DX. But if we are programming in 32 bits, we can use EAX, EBX, and ECX, and all of this lah, because this is the code that is predefined inside your assembler. Okay, so for the 16-bit programming, you also can move around the data using AH, AL, because it is inside this AX. Okay, so AL is actually from AX. Okay, so AHAL, BX containing BH, BL. Okay, so actually L ni it is specifying low, meaning lower byte of AX, and then higher byte of AX. Lower bytes of lower byte of BX, and then this one is higher byte of BX. Okay, so AL only containing 8 bits, AH only containing 8 bits. Okay, so AX only can occupy until 16 bits, and then EAX can occupy up until 32 bits. Okay, so for this one, it will cause error because the count is in byte. So dia tidak cukup. The bytes is only at bits kan, and then you want to put it in EAX, and then you want to put it in AX. So if you can see this, AX should containing 16, but your count only 8 bit. So you can put count inside AL saja, or you can put the count inside any of this AH or AL or BH or BL.
Why right put AL into count one?
Pardon?
Why this says move AL into count?
AL into count, because we want this count holding the value of AL.
AL got value. Is it?
Yeah. So we didn't specify what is the value of AL here, because AL is the registry inside our computer kan. But we don't know the value lah. But we can assign the value inside the AL into this variable.
The count not empty, right? So you can move. So it moves.
It can the count is not.
Is it empty after moving the byte into BL?
It will not empty because it will hold the value of the AL.
No, I mean before this.
Or like before this,
after the count byte put in move got the byte moved into the BL. Does it still have the byte 100?
Pardon, I cannot understand your question.
The first one you write the count, the byte the byte 100 in the count moved to BL, but after it get moved, and then does it still have byte down 100 inside?
Oh, yeah, because even you move it, it's still counting. It still have this. The only difference is BL now having the same value or as the count. Okay, so after that, the count value only replace or change from 100 to the value of AL during this instruction. Okay.
Oh,
Okay. So when you are um, coding in assembly language later, I think this diagram is helpful lah later, because um, we sometimes it will throw error in your programming here, even during your declaring the data. We don't know because sometimes dia punya felt kan this one, if you guys can see, dia punya error that will come out is instruction operand must be the same size. When you move something that is not in the same size, for example, this one, you want to move count to EAX, you want to move count into in AX, because it doesn't have the same size, so it will throw the error like this. Instruction operand must be the same size. Okay, so we proceed. So that's why, because of the error like previously, because it doesn't have the same size kan, so that's why zero extension is needed. Okay, so when you copy a smaller value into a larger destination, the MOVZX instructions is needed because this instruction will fills or extend the upper half sorry, because this instruction will fills or extend the upper half of the destination with zero. So can you understand that statement kan? Okay, so let's say you have this value, and then you want to put it, because for example this one lah, you want to put count which is only in byte at bit, you to this AX. This AX is 16 bit. Okay, so you only have this count. For example, this is the count lah. So you need to use the MOVZX to avoid the error like this, because by using MOVZX, it will extend or fill the remaining empty bits to zero. So it will make this from this one to this. Okay. Okay. So yeah. So we need to use move ZX to solve the problem like this. So this one, of course, dia akan ada error because we didn't use MOVZX. So the rule for this, for using this instruction, is your destination must be a register. You cannot use MOVZX to this, because this one is not register. It is only a variable. So to use the MOVZX punya instruction, you must the destination should be register punya nama. It cannot be a variable. Okay, so after that, we proceed to the sign extension. So this sign extension is specified by this instruction. Okay, so this instruction, which MOVSX, it will fills the upper half of the destination with a copy of the source operand sign bit. Okay, so let's say you don't know, you only have the this at bit value, and then you want to put it in this destination. So if you use this MOVSX, it will not produce error when you want to move this to this if you use these instructions, because this instruction will fill in the remaining empty bits with the operand sign of the with the operand sign bit. Okay, so if your value here is positive, then it is negative. Also, it will fill up the remaining empty with 1. Okay, so there's also it has the same rule with the MOV ZX previously. The destination must be registered to use this MOV SX. Okay, so after that, we proceed to XCHG instruction. So this XCHG stand for exchange. Okay, so these instructions can exchange the value of two operands. At least one operand must be a register. Okay, so no immediate operands are permitted. And so what is actually the immediate occurrence? So immediate occurrence is actually the constant value or the result of the constant expression. So the assembly encodes the immediate values into the instructions at assembly time. So here are the some here are some typical examples showing the immediate occurrence. So we cannot, this is the example of immediate occurrence. So to use these instructions, you cannot use or you cannot exchange the value of immediate operand. The immediate occurrence is the example is your constant nila, the constant value or constant expression. Okay, so this is the example of how we use the exchange instruction. So let's say you have these two variable. So you want to exchange their punya value. So you just put it like this lah. So exchange AX with BX. Exchange AH with AL. Okay, so exchange var 1 with BX because var 1 is in word. So in word meaning 16 bits. Okay, so BX is in 16 bit, is a 16-bit register. Okay, so this one is you want to exchange the 32 bits register. So you can exchange a value of two operands, but it must have the same size. Okay, so if you want to change this var 1 with var 2, it will cause the error because the rule here is at least one operand must be a register. This one is both of this is the variable kan, so cannot. So to use these instructions, we need to use either one of these operand should be a register. And then another rule is each of these operand must have the same size. Okay, so if we can refer to this diagram again. Okay, so if you see here, AX can be changed with BX, AX can be changed with BX, AX is containing AH and AL, BX is containing BH and BL. So these two having the same size. So that's why we can use exchange to this register. And then you can exchange AH with AL. You can exchange the value inside AH to AH, and then you can exchange the value of AH to AL. Okay, so after that, you can change also the var1. var1 is inward type, inward size. So inward size meaning 16 bits. So 16 bits you can put in BX because BX holding 16 bits data. Okay, so EAX, EBX is the holding 32 bits. So that's why it can exchange. But this one cannot because both of the operands is variable. The rule of the exchange is either one must be a register. Okay, so we proceed to direct offset operands. This direct offset operand will add this direct offset operands, it will make a constant offset is added to a data label to produce an effective address. So the address is the reference to get the value inside the memory locations. So meaning to say that direct offset ni, you can use this instruction to add an address to your variable. Okay, so let's say you have this variable, it is in size of byte, so it is array. So you the direct offset here is meaning to say that you add one, to the address of this array, so that so dia punya syntax here is you can add the operand or the constant offset, you can directly add it like this. Okay, so for example here, you want to move this array to the location of this. Okay, so if you plus 1 here, it means you are choosing this one. Array B plus 1 is the location of this. So that's why your AL will containing this value from this array. Okay, so alternative notation is like this. We can also put this square bracket. Okay, can understand here?
Yeah.
A bit.
Okay. So why? Okay, the question here is why when we add the array B plus 1, it didn't produce 11H. Because if you see here, you can, if we think maybe 10 plus 1 should be 11 lah kan, but why it is 20? Anybody can answer?
You just choose the next one.
Because what it added here is not the value. It added the location or the offset. Offset is actually the address inside the memory. Okay, so when it add here like this, it doesn't add this one to the value of the array. It add at the offset. It add this +1 to the address of this one. So that's why it choose 20, because the new address is pointing to the address of this one, the second array. Okay, so we can also write this by this one lah. We can add square bracket. Okay, so after that, this is the continue of the offset just now. Okay, so a constant, this is the same instruction, the same description like the previous. Okay, so this is another example lah. So let's say we have this array. So it is in size of word, and then this one is in size of double word. Okay, so if you want to move this value to this location, so you will get array W ni, array W is this one. You want to add 2, meaning 1, 2. So that's why your value is this one. X value is this one. And then after that, you want to move the location of, or the value of this array in this location, which is 1, 2, 3, 0. Location of this is this. Actually, I think this is not 4 lah. This is, I think, 1, and then this is actually, yeah, this is actually 1. Yeah, Noel?
The second line isn't supposed to be 2 plus 2.
Yeah, yeah. So I think this is wrong lah. We follow the rule in this kan. If we +1, meaning the location of this plus this. So it should be 20H lah, the second location. So for this one, to get this one need to add 1, and then to get this one need to add 2. Okay, so I will directly correct this one. Okay, so this one should be 1. Okay, so this one should be 2, so that we can get this value. Okay, so for the EAX, because this is already kan, already is in 32 bits, so we want to this one is not 4, this one is actually 1, because the value here is 2. This 2 is this one, if I'm not mistaken lah. Okay, but the concept is the same. What you want, you can add the constant offset inside an array to get its value, or to add the address, or to increment the address, so that you can the value of the specified address that you already put here lah. Okay, so this one I think this is wrong, but I think this is maybe 1 lah. So this one just ignore sebab dia punya the example is wrong lah. Okay, so as long as you guys can get the concept. Okay, so we can add the offset, constant offset to the address of the array to get the value. Okay, so after that, okay, so this is your turn. Before that, I want to ask, Farah, you already can run bahkan? You already upgrade bahkan, and Kelvin, you already upgrade your Visual Studio to 2019?
Yeah.
Yep.
But if I remember it correctly, Kelvin said your computer is a little bit slow lah sudah.
Oh, yeah.
Okay, so later you try to do this, or maybe we can. I think this exercise we can do tomorrow lah, because we want to rearrange this array to this array. So tomorrow we will use the direct offset to rearrange this array to be in this arrangement. Okay? So make sure you, because all of you already can run the 2019 punya Visual Studio, then okay. So we will try this tomorrow. Okay, so after that, okay, so this will also, we will evaluate this tomorrow after we run. We can exercise this tomorrow. Okay, so 71 and 72 will be tomorrow. I mean the page, when I said the 71 and then 72 is tomorrow. 71 plus 72. Okay, so, and now we are proceeding to the addition and subtraction. So we will learn about the increment and decreasing, increment and decrease, increment and decreasing instruction. Okay, so we can add one or subtract one from the destination operand. The operand may be register or memory. So the operand, your operand must be either register or memory. So you can add one, which is we can use INC instruction to the destination of your operand to add one. Okay, so we can also use this DEC instruction to your destination to decrease or subtract one. Okay, so what is, we will see the example. Okay, so for example, this one, let's say we have two variables here. Okay, so we use this INC, meaning to say that we add one. So if previously, so this INC and DEC ni, it will add the value of that variable. It will add or it will subtract one from the value of your variable. if previously the offset, we directly add here kan, add +1. So it will add the address of this variable. But if we use the INC, it means that we adding or we increment the value of this variable by 1. So if the previous value of this is this, and then when we use the increment, then meaning to say that we add 1 value to this variable. So when we use this to this variable again, so the current value of this, my word, is equal to this, and then we decrease it again, then it can get its previous value lah. So the same with this D word. This D word, because if we increment it with 1, meaning the value is incremented with 1. So this is some of the example of how we can use the increment lah. Okay, so we can just directly increment the register name, but it will not it will, meaning it will increment the value inside this register lah. Okay, so if previously this register have this value, but then after that we increment the AX with 1, so the value is now is this one. So we cannot see the difference here because it is in hexadecimal hexadecimal punya format. So but it means that from when we increment 1, from this value it will become this one, but it is in hexadecimal, so we didn't directly see the difference. Okay, so so this one also you want to, you specify the value of AX now, which is in this, and then you increment the AL. This one. This one is actually AX ini. AX nih, but this is wrong. So this is actually AX. Okay, so the current value, when you increment 1 of this, it should be, actually this one is repeating. This one is repeating and wrong. It should, yeah, so we just focus on this one lah, and this one. So remember, INC and DEC, it will add the value or it will decrease the value of the variable lah. But the offset just now, it increasing or it add the value at the address of that variable. So we proceed with the add and sub instruction. So add, this is the syntax of adding. So you can use add and then followed by the destination and the source of the variable or any variable or register lah. Okay, so the sub also, it should have this syntax, which is destination and source. Okay, so it has the same rules with MOV instruction. So whatever rules in the MOV instruction that we have learned previously, it can be applicable to sub and add. So after that, this is the example of add and sub. Okay, so let's say we have two variables in size of D word, which is 32 bits. Okay, so after that, we want to move the variable 1 inside EAX. So remember why we use EAX, because it is in 32 bits. Okay, so after that, we can add the value inside the EAX, which is now has the value of the VAR1. We can add the EAX with the VAR2. So this is how we can add variable 1 and variable 2. So how we can add it? By first we move the variable 1 to EAX first. After that, we can add the variable 2 to the EAX. So um, it will get this value lah, because one this 1000 plus 2000, it can become 30000 hexadecimal. Okay, so we can also directly put a constant value here. So this is EAX, which is 16 bits register. So we can just directly, it doesn't need to be in variable. So we can, in MOV rules previously, it must be a register and a constant, or I mean, it should be at least one register. So we can directly put the constant inside this X register. So after that, you can also subtract 1 from this value, which is now inside the AX register. So the value now is like this lah. Okay, so for EAX, you can add 1 value to the EAX. So EAX now is this one. The value of EAX now currently is this one. But if you add 1, then it will become this one. Okay, so for this one, the value of it now is this one, and then after you subtract 1, it become this one. So we don't know how correct is this.
Why like that?
Yeah, itulah. I
Should be
think it should
3.
be 2. Kan?
Should be
2
2.
FFFF.
Should
Because it
not 3 FFF.
not what?
Not 3.
3, this one. Because you want to add, I mean the current value of AX is actually this one now. And then after that, we subtract 1 to from this one. So it says that it become this one. So to verify this, don't worry, we go to this one. Okay. Okay, so in this is in hexadecimal. If you want to wait, EAX is actually containing AX. Okay, so if we refer to this, EAX containing AX. Okay, so if you add this one, because EAX now is this one, the value of EAX is this one. So you add this one to this actually. So it become 3FFFF. So after that, you subtract 1 from this. Okay, so we copy paste this first. And then we change it to decimal first. So actually it is this value. Okay, so after that, when we subtract 1 from this, hexadecimal calculator. So you can get all of this calculator online. Okay, so this one plus, bukan plus, minus 1. So it should FFFEE. FFFEE. I don't know either this is wrong or we calculate it wrong. But anyway, I will get back to you guys later about this. Can Calvin? Okay. So this one I will highlight first because we are not sure about this. Okay, so we proceed. After that, we proceed to the nig. Nig meaning negate. Negate meaning we reverse the sign of an operand. So your operand can be a register or memory operand. Okay, so for example, you have this variable. So this variable in size of byte, so it is in negative. So this is sign integer lah. Okay, so after that, we use the neg to reverse the sign of the operand. So if we now we are assigning this value to AL. So now the value of AL is -1. So when we do the instruction NEG to AL, so now the AL value is positive lah. Okay, so because it's only reverse the sign. So the same with this. So if we impose the negate instruction to this VALW, so it now become this negative. Okay, so there's the questions here. Suppose AX contains negative 32768 and we apply neg to it. Will the result be valid? Okay, so if we refer to word just now, it says that in 50 something to 50 something word. For word, this is the smallest sign value, 327 at 6 at. So this is the smallest value that can be this is the smallest. Okay, beta. After that, Okay, so the smallest value for word is this one, 32768. 32768. Okay, so when we apply the negate to this, it will become positive 32768. So will the result be valid? What do you guys think? Valid or not?
No.
Why do you think it is not valid?
Because reach the maximum already.
Yeah. Yes, correct, Noel. So, if I'm not mistaken, the largest word the largest value that it can store is this one. So, when you negate this, it will become, um, um, it will over this value lah. So, the result will be invalid. Okay, so now we proceed to the offset, PTR, type, length of, size of, label. Okay, so this is all we called as data related operator and directive. So we will know each of the function of this one lah after this. Okay, so for the offset operator, when you put offset inside your, when you declare a verb, when you in your instruction, it will return the distance in byte of a label from the beginning of its enclosing segment. In short, actually, when you put offset, it will return you this part. Okay, so let's say you have a variable for this. I mean, yeah, the variable, you are given a variable. Your variable will be stored in the memory in this format, kan? So there will be a offset. There will be a binary that allocate to determine the offset or the address of your data, and then there will be a place to put the value of your data lah. So if you use offset, it will return you the address of your variable, only this part, I mean only the offset part lah. In short, it will give you the address. Okay, so okay, so the for protected mode for the 30 bits program, we only use one segment. Okay, so one segment here meaning one part in your memory. So in one segment containing offset and then the value. So this is the example of how we use the offset. Okay, so let's say all of this value, or before you start declaring this in the database, memory. In the memory, your all of this data is you start all of this data is we start save or allocate this data at this address. Okay, all of this. Okay, so let's say your memory start with this, and then you already declare this one, this one. So your first variable will be located at, because it is start with this address can, or with this address segment, this data segment or this address. So your first variable will be start with the starting address. After that, your w-val, because it is the second variable, it will be put at the next segment, which is you increment it by 1. So after that, because this is the D word meanings it is 32-bit. Okay, so let's say your this one, your segment is only 16-bit. So that's why for the D-val, it is it is started at uh, location 3, meaning because Word is using 2 segment already. Because imagine that this is every segment of your memory, it only containing 16-bit. Okay, so when you first place the byte, it will occupy the first segment, because your segment is wait sorry, this is 32-bit. The one segment here is this is one segment here is 32 bits. You remember the protected mode? Protected mode meaning to say that you cannot suka-suka hati place any data inside your memory. If you remember last time we have learned about protected mode and then real mode. So in protected mode, when you put your data, it must be in sequence. So let's say that in your memory, one segment is containing 32 bits. So when you declare first variable, which is in byte, it will occupy your first segment that is started with this address, and then it will occupy first segment. Okay, so for byte meaning it occupied at bit at the first segment. After that, you declare a variable which is in size of word. So your size of word is word is 16-bit. So it will be stored at the next sequence of that of the segment. After that, the devolve, because it needs to use, because dword kan, dword it needs to use 32. It should be better, I think first. Okay. this is 32-bit because if you see here, it is ESI. ESI register, meaning it is in the 32 bits. ESI. ESI here. So ESI is 32-bit. So this is 32-bit protected mode. So all of your data should be in sequence. But the word it use the word this one is should be 16 bits, so it can be enough in the next segment. Then after that, the word 32-bit, and then this is can you guys see the what the can you understand this, or do you, because I am a little bit confused lah. Noel, can you see, or can you tell why this is tiba-tiba 3 and then this is tiba-tiba 7? Based on the D word and based on the size of this variable. If cannot, then it's okay. I will get back to this later, because oh yeah, I think I know already lah. If you guys remember the video last time, I showed you about the protected mode and then the real mode. It will put the data, yes, in sequence, but it doesn't need it really in sequence, but whatever you want to put, it must be in sequence lah. But for the first variable to the second variable, it doesn't need to be in sequence. It's just that you cannot split any variable to different segment. I mean, the segment that put one variable must be in sequence. So maybe we can put the variable this into this. After that, maybe the segment 2 is occupied by another program or another data. So we can put, so the system put the third variable in the next empty segment, which is in 3. So after that, but the default must be put in sequence. It cannot be, if in the real mode, if you remember last time, you can split the data and then put everywhere in your memory. But in the protected mode, you can put sorry, you cannot split this variable or this instruction into 2. So, but it must be, I mean, in your, when you specify a variable inside memory, it must first occupy the empty segment in that memory. Okay, Kak confused already. Hello? Kelvin?
I don't understand.
Don't understand lah. In short, don't understand lah kan? For Noel?
Still digesting.
Pardon?
Digesting.
Digesting. Oh, digesting. Okay, so I think if you really don't understand about this, I think I will get back to this later lah by showing you again the video that I showed last time. Okay, page 81. Okay, so we proceed. So this is how we relate with the C++. We relate the offset to the C++. So in the C++ version, when you want to get the position or the address of an variable, you put it like this. Have you guys learned C++? If I'm not mistaken, yes, kan? C++?
Yeah.
Okay. So you know about this lah, kan? So what is this code tell? What is this instruction? Can you explain?
I think I forget already.
Oh, Kelvin?
Pointer, I'm not good.
Pointer, you are not good in C++.
Yeah.
Okay, Farrell, have you learned C++?
Yeah, but I
Oh,
think I'm not good at this one also.
okay. So in short lah, C++, I am also not, I learned C++, but it was 10 years ago when my degree lah, because it is the first programming language we learn. But if I remember, this is the syntax how we get the address or the pointer of this array. Okay, so in assembly language, we use, like previously, we use offset. Okay, so we use offset to get the address of the array. Okay, so this is the difference lah. How it is done in C++ and then how it is done in assembly language. Okay, so we proceed to the PTR operator. So this PTR operator, it provides the flexibility to access part of a variable. Okay, so it will override the default type of a label or variable. Okay, so when it says label here, actually it is referring to a variable. Okay, so let's say we have this variable. So it is in size of D word, 32 bits. And then this is its value. It is in hexadecimal. So okay, so you need to use PTR to extract the value of your variable. Okay, so if you see here, but how many you can extract or how many bits you can extract is depending on your register. Okay, so if this one can, it will cause the error. Why? Because AX is 16 bit, whereas your my double is in D word. D word meaning 32 bits. So it will cause error because you want to put the 32 bits value inside your AX, which is only can hold value until 16 bits. So that's why you can use a PTR operator to extract only 16 bits or only the value that can be put inside the AX. So, but you need to specify the size lah, or the size of your words that you want to extract also. So this is how you can do it. First, you want to, because you want to move in the AX kan, so you need AX only can hold value until 16 bits. So 16 bits is equal to word. So that's why you can extract, you can use this operator to extract the value inside the my double. So, but you can extract up until 16 bits only lah. So that's why, because this is in hexadecimal, so this is actually in 16 bits also lah. Because if you remember, so this is actually 16 bits. If we convert this into binary, so this is, you can, so we calculate first lah. This 4, this is 4, this is 4, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so it is 15 bit, but we can always put 0 when it is not enough 16 bit, as long as it is not over than 16 bit lah. So it is okay. So we extract a word size from this my double. So you can put it inside the AX. So that is the responsibility of PTR, meaning we can extract. But this is the syntax lah. When you want to extract, you need to specify in what size you need to extract. Okay, so so another use of PTR is you can specify what value that you want to extract. Okay, so let's say you want to extract this value from this, because it's hexadecimal, so we cannot see it clearly lah, this value, because actually 2, 4, 3, 2, 1. So it is in it only want to save this part. Okay, this is actually we can say that it is the MSB, the most significant byte. Okay, so by using the PTR, you can also specify what part you want to save, but as long as it is in word lah, so you can specify what part you want to save. Okay, so after that, you can also use the PTR 3, 4, 5, 6. 3, 4, 5, 6. Okay, so you can also specify the location that you want your, macam mana? It is like if you are familiar with SUB or subtract, or in higher level punya language, you can extract in Excel, if I'm not mistaken, has that function also lah. If you want to extract some part of the words or text, you can specify from which location or from which index you want to extract the value. So it is the same concept with this one. So this one you can also specify from which location of this you want to start to extract. Okay, so for this one, for example, you want to start to extract this one from starting from this location. So we starting from this location. If I'm not mistaken, this location maybe from this one. Okay, because if you plus one, it will get the second location kan of that word. So you can get this because it is in word size. So from this location, which is 2, you can get this, you can extract this value because it is in word size. Okay, but I think when you learn later about the PTR, you can search in the tutorial this in this this tutorials point about the programming language. It is the details of each of the operator here, operator procedure. So you can search about the PTR lah if you want to use later. But how many of you have used the SUBSTR subtract string from Excel or any programming language that you use, that you have used previously? Adakah?
What? Abstract.
Iya, dia macam wait, I will show you in the Excel lah. In Excel, let's say I have this word, and then I want to use SUB substitute any or extract. Excel. If I am not mistaken, in C#, we have one function called SUB substring macam tu lah. So in this substring you can extract, or you can extract from what location, from what location you want to extract. Okay, so it has the same concept like this one. Okay, so in Excel we don't have that function, but I can show you the replace function. So this replace function, so macam ni lah, you can replace all text or whatever text that you want to replace with the start number, and then start number meaning the location of the first character or text, and then the number of character that you want to extract starting from the start number, and then you can replace you replace with, you can put the new text lah, whatever you want to replace the old text to. Okay, so I cannot show you guys in the Excel. If I want to show the function, it is in C#, but I don't have a program in C# now. So as long as you guys can capture the concept lah, okay? Can you understand this one? Usually this is showing the location or the location that you start extracting the value until the size of word. I mean, you can extract the value starting from the first, from what it is specified here until the size of word. Okay, for example, if you start from here and then you can get until, you can extract until 16 bit of this number. Okay, to binary, so we go. So let's say, because that is in the hexadecimal kan previously. Okay, so let's say we convert all of this into binary. So if you want to extract these instructions, meaning to say that you want to extract 16 bit of a value from this, starting from the location that is specified in here. So let's say my double plus 1, its location is this one, 0. And then you want to extract 16 bit because it is in word. So you need to calculate 16. 1, 2, 3, 4. So that's mean you extracting this one. That's why you get this. You will get what you extract lah. So the value maybe this one lah. Okay, I hope you guys understand lah. Later when you do your program, you can explore this more.
Miss, the
Yes.
exercise need to do as a homework.
Exercise.
Yeah.
Yang which one? Yang the previous?
Oh yeah.
Oh, yang just now yang I show, which one pa? Yang this one, your turn. We will do it later, tomorrow.
Oh.
This one, huh? Okay, so we will do this tomorrow together.
Okay.
So, ayo, jam 4 sudah. Okay, so our class is until 4, right? Do you have class after this?
No.
No.
Oh, okay. So wait, I will see first. Okay, so this one also we will do tomorrow. Write down the value of each destination operator. Okay, so this one also we'll do tomorrow. Can we proceed to, can I get your time? Can I borrow your time about 15 minutes?
Can so?
Okay.
Okay, thank you. Okay, so after that, we proceed to the type operator. So we use this type operator to return the size of your variable in bytes. Okay, so remember it is in bytes of a single element of a data declaration. Okay, it means that the single element of the data declaration. So when you declaring a variable, and then you use, you have this variable, and then you use type operator, it means that you will get the size of this variable, but in size of bytes. Okay, so if you don't know what is how much is the size of byte, so you can use type operator lah. So if you see here, we are we want to move, actually for these instructions, we want to insert to a EAX register the size of var1. Okay, so if you remember, byte is at bits kan, but this type it will return the size of the variable in bytes. So byte is actually 1 byte saja, so that's why it will return 1. Okay, so for the word, it is containing 16 bits. 16 bits is equal to 2 bytes. So that's why it returns 2 when you use type. Okay, so after that, for the D word is actually 32 bits, which is equal to 8 bytes. Because if you divide 32 with 8, you will get 4. So that's why it will return 4 bytes. Okay, so for this one, keyword is 34. 34 when you divide by 8, because it is when you divide by 8, so you will get 8 bytes. Okay, so understand kan? This one is easy kan? Okay? Okay. So another operator is length of. This length of, it will return the counts of the number element is in a single declaration. Okay, so meaning to say that, for example here, you want to know the length of this array. This array, you want to know the length of this variable, byte 1. So if you see here, this is also an array lah, but array in type of byte. So you can see that this is a 1, 2, 3. So the size of this is the length of this 3, because this length of it is calculate, or it counts the number of element. So this one, the number of element in this array is 1, 2, 3. So that is why it is 3. So but for this one, it is 32, because this array, beside it is allocating 30 elements in that array, it also adding another 2 element inside it. So that's why it is 32, because this is the declaration of array with 30 element inside that array, and then it is adding another 2. So that's why it is 2. So after that, for this example, this is actually the array with 5 elements multiply with array that has 3 elements. So that's why it is 15. Okay, so after that, the D word, this is exactly, you can see exactly the number of elements here lah. So that's why it is 4. 1, 2, 3, 4. Okay, so after that, this one is 9, because it calculate, if you remember how the string is stored in memory. If you remember last time, each of the character inside the string, it will be stored as an array inside memory. So that's why each of the character inside this element inside this string is actually one array element. So that's why if you calculate here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 element plus another 0 here. So that's why it is 9. So length of meaning it is calculating not the sum but the count of the element inside either it is a string or array. Okay, so this is the example of how you can get. You want to store the value of the size of the length of this array into this register. So it is 32 because it is array 1. Array 1 is this one. So after that, size of. So this size of is actually equivalent to the multiplying the length of size with the type. If you remember just now the type and the length of, so that's why you can get for this byte 1, when you are imposing a size of operator to them, is if you remember the length of array 1 just now is 32 kan 32 because 30 element plus this 0 and this 0, so there are 32 element inside this array 1, but it is in type of word. So word will return the type of word will return 2. If you remember last time, word is equal to 2. Okay, so that's why the size of is multiplying the length of with the type. So that's why 32 multiply with 2. So it become 64. Okay, so you can calculate the size of all of these apalah letter. Okay, so for example, this one kan byte. So the length of is 3, but byte is 1. So the punya value is 3 lah. Because 3 multiply 1. Okay, so for this one, it is because the length of this is 15. So you multiply with 2 because the type of 2 we will get 2. So that's why 15 multiply 2 equal to 30. Okay, so after that, so this one direct addressing we will continue tomorrow lah. Okay.
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 Okay, thank you for your focus. Okay, bye all. Sorry to get to borrow your time.
It's okay. Thank you, Miss.
Okay, bye.
Okay, Miss. Thank you.
Okay, bye.